In today's lecture, I'd like to talk about a specific kind of non-standard annuity called an annuity due. Now, recall your definition of a standard annuity. I've got it illustrated here. A series of equal payments, equally spaced in time, starting at the end of year one, where the compounding period and the payment period is the same. Now, an annuity due is just a small variation on that, shown in the diagram below. The appearance is exactly the same. The only difference is, with an annuity due, the first payment happens now, at the beginning of year one, or if you like, at the end of year zero, as opposed to at the end of year one with the standard annuity. And this happens often enough that it's worthwhile recognizing specifically how to deal with this situation. And I'll give you an example problem. A car loan requires 30 monthly payments of $199. Starting today, at 12% compounded monthly, how much money is being loaned? So we're looking for a present worth, the money being loaned. We're given an annuity, $199. And we have a number of periods and an interest rate. So it's simply a present worth problem, a series present worth problem. The only difference is that the payments start today. So we've got an annuity due kind of situation. Now, I'm going to be talking about 3 different ways of dealing with annuity due, all of which give rise to the same result, but involve looking at the problem in a slightly different way. So let's talk about the first method. If we look at this annuity due structure, if we take off that first payment, just ignore it, we have a standard annuity. A standard annuity of one payment less than the 30 in this case we're given in total. So it's a standard annuity of 29 payments, plus a present worth value equivalent to the amount of the payment. So method 1 is to take that first payment as a present worth already of $199, add to it the $199 annuity over 29 periods converted to a present worth at 12% interest, but for 29 periods. Yeah? And this value is 25.062, giving rise to a calculated value of $5,186.34. So the logic of that's fairly straightforward. Let's look at the second method. If we took each of these payments, every single one of them, and moved them forward in time 1 year. So this payment, we found an equivalent payment 1 year in the future. And for this one, we find an equivalent payment 1 year in the future for it, and so forth. That would convert this annuity due into a standard annuity over the 30 periods. So what we do is we take the $199 payment and we take it to the future at 12%, 1 year. Now every one of those payments, that calculation is the same. So we just need to do it once. And then we take the result and find the present worth of that now standard annuity at 12% over the 30 periods. This series present worth factor is 25.804. This compound amount factor is 1.01. If we multiply that out, that equals $5,186.34. The method of determining that value is different, taking a different point of view on the problem. But the numbers work out to be exactly the same. And a third method. Another way of doing this is to recognize that this is a standard annuity, It is a standard annuity if you place your perspective at year minus 1. If you imagine yourself a year ago, if you like, looking at this problem. It is a standard annuity. As you can see, it follows exactly the same pattern as the one above. Mathematically exactly the same, except we've renumbered the scale. So we can find the present worth, this present being perhaps a flexible word, a present worth at year minus 1, a year ago. That's not what we want. But if we do that, we can then take that present worth a year ago and move it forward, or find an equivalent value today to that present worth of a year ago. So it's another way of looking at the problem. And in that case, we take our $199, we find a present worth at 12% over the 30 years, right? There's 30 payments now because we're just considering it to be a standard annuity at year minus 1. So all 30 payments count. That calculation gives us a present worth a year ago. We can then bring that to the future. One year to find the equivalent today. Now, this and this, 2 and 3, are exactly the same mathematically. You see our compound amount factor here, and our series present worth factor here, and the $199. So it's all the multiplications exactly the same. So it has to be equal the same. It's just that our perspective on determining the formula was different. Now, you don't need to memorize all these different ways of calculating an annuity due. One of the purposes of demonstrating this is to give you some idea of the different ways you can look at these cash flows in order to calculate whatever you're trying to calculate. It's a matter of understanding how you can interpret a cash flow in an appropriate way. You can move money through time, as I like to say, or find equivalent values at different points in time for different series of payments. But these different perspectives give you different ways of looking at it that you can use in problems in general. And we'll see, in fact, when we look at deferred annuities and gradients, that this third method is really just a specialized case of the general principle we use there. Thank you.